Hello, welcome back to Genius. Okay, so in this session, let's talk about sets. Let's talk about sets in Python and why we need them and how we use them and why we need to have them in our program. Okay, so in Python, a set is an ordered. It is an unordered, all right? It is not ordered. List, dictionary, tuple, they are all ordered, all right? They come in a certain order. The way you put them is the way you get them. But set is unordered, and it is also a mutable collection of unique elements. That means the elements you store in a set, they are all going to be unique. You cannot have duplicates. All right, you cannot have duplicate elements in a set. The set is mutable. You can make update them. You can add something to them. Okay, something like that. All right. So sets are useful when you need to store multiple items without duplicates. All right. So when you want to store some data that wouldn't have duplicates, you use sets. When you want to perform mathematical set operations such as union, intersection, difference, and symmetric difference, that's where you use sets. Okay, basically, if you want to have a data structure that does not have duplicates of elements, you use set. If you want to perform mathematical set operations like union, like intersection or difference or symmetric difference, you use set. Okay, so how do you create a set? You create a set using the curly braces. You might be like, we also create dictionary with the curly brace. Yes, but when you create a dictionary with a curly brace, dictionary will have key value pair, but sets don't have key value pairs. Okay, so you can also use the built-in set function. All right, so curly brace like this. Okay, when you do something like this is a set. It is not a dictionary. All right, it is a set. Okay, and then you can also create using the set function. So this is an empty set right now. So let's go to code and see something. Let's do some things here. Okay, so basically, um, okay, I would have let's say I want to have, let me just call it A. For whatever reason, I'm creating this set. One, two, three, four, five. Okay. Then I'm creating a set using the curly brace. I can also create another set using the um, set function. Now, the thing is this. If you try, normally we could say if you want to create an empty set, we'll do something like this. If you do something like this would be a dictionary. This would be a dictionary, so you don't do something like this. When you use empty set, you're creating a dictionary. To prove that this is a dictionary, let's go and print the type of this object, and we'll print B. Let's see what it gives us. You can see it gave us dictionary. So if you want to create an empty set, you use the set function. If you use the empty curly brace, you're creating a dictionary. So you use the set function to create an empty set. Okay? All right. So this is how you create a set, and the elements will become separated, and then this is how you create an empty set. All right. So if you, like I have just mentioned now, if you use empty curly braces without having elements inside of it, you'll be creating an empty dictionary, not a set. So if you want to create an empty set, you use the set function. All right. Don't use empty curly braces. Okay. Now, what are the characteristics of sets? The first one we have is it is unordered. That means the elements have no specific order. Okay, let me show you something now. Let's go back to code. You see this thing that we have here. Let me print. I'll keep on printing this A, uh, and let's see if the order changes. Okay. Okay, this might not give me exactly what I want. It might not give me exactly what I want, but I don't know the best example to show here. But the thing is this: these things are unordered. All right. Okay. How do you know? There is one. Okay, we'll get to that when we talk about the pop method. Okay, so we'll get to that. So if they are unique elements, you cannot have duplicate elements. All right. Even if you have duplicate elements, they will be automatically removed. So let's say in this my set now, I have four here. Okay. Look at it. If I print this set, if I print this set, you're only going to see just one 4. You're not going to see the two of them. Okay, you're not going to see the two of them. Okay, okay. So, in as much as this 4 here came here, but even here it was a kind of sorted or something. Okay, all right. So now they are mutable. Yes, you can add and remove elements. It's only tuple that is not mutable. Once you create a tuple, you cannot change the elements of a tuple. List, dictionaries, and sets, they are all mutable. You can change their elements. You can remove them. So immutable elements, set elements must be hashable. So you can, if you want to, the kind of elements you have in a set are elements that are immutable types. Okay, so what it means is this: the elements of a set will always be immutable types. You cannot say this. You cannot come and say this set um, contains tuples like this or strings like this. I mean list and tuple. All right. If I run this code now, there will be an error. The elements of a, look at it, it says type error, all right, unhashable type list. So you cannot have list and tuple, they are not hashable. It means that they are mutable. So your sets cannot have the elements of your set cannot be mutable elements. All right, they cannot be mutable elements. The set itself is mutable, but the elements cannot be mutable elements. So how do you add elements? You use the add method or the update method to set or you update the set using the update method. So if you want to add elements, you can call the add method. Now we have 1, 2, 3. So set.add. I don't need to write any code here. For you to get to this level now, you know how to use methods on data structures like this. So when I say my set.add, all right, I am adding 4 to it. So if I print this, I'm going to get 1, 2, 3, 4. You see, 4 has been added to it. Okay. Then if I also want to add multiple elements, okay. Now look at now, you would say, we already say that sets don't take mutable elements, and we are having a list here, and we're also having another set here. Now the thing is this: if you call the update method and pass in these objects here, look at what is going to happen. You see the result. Okay, you see the result. 5 and 6 were added, 7 and 8 were also added. You get? So 1, 2, 3 was the initial one. So we added 4. Then when you call this array and this new set on it with the update, this update will convert everything, would actually flatten it, and you would get a simple set like this. So let's go to code and let me show you something. Okay, so we have this 1, 2, 3. So I want to add a new item, a new element to this. I will say a.add. I will add 4. All right. And if I go ahead and run this code, you see 4 has been added to this set. We are printing A and 4 has been added. If I also go ahead and say a.update, all right, then this can take in it can take iterables. I can say I want to add 5, 6, 7. Oh, sorry. So it will take a list, or it cannot, or take another set. All right. 7, I will say 8, 9. Sorry. Then let me try to add a tuple, and I will now say 10. Let's run this code and see what we get if we. All right, you can see. Now the thing is this: with this update method, you can actually add a list. All right, you can actually add another set. You can actually add a tuple. So in case you have a list, or you have a tuple, or you have um, any mutable element that you want to add to the list, maybe you could just maybe create an empty set, then call the update and pass things like this. So if I imagine that I create an empty set here, all right, I could just say empty set. Okay, so without calling the add function, let's see what we get. All right. So now I'm adding list to all this to this update. So if I run this code, I'm going to get 5, 6, 7, 8, 9, 10 in the list. Sorry, in the set. Okay, you can see. So I created an empty set, and then I can use the update in case I have some data in a list or some data in a tuple. All right. I can actually go on. So even a tuple can be an item of a set because tuple is hashable, tuple is immutable. All right, so um, tuple can also be an element in a set. Okay. Then how do you remove an element? You use either the remove method or the discard method or the pop method. So if you try to use the remove method, now if, in case this key, the element you're trying to remove, in case it is not found, it will throw an error. So let's go and do remove. So after updating this my set, I want to remove. I will say a dot remove. And I'm going to pass in 1. Remember, we don't have 1. We don't have 1 in this set. We only have 5, 6, 7, 8, 9, 10. So if I go on and run this code, we are going to get an error because 1 does not exist in this set. So we got a key error. So if you use remove and the keys does not exist, it will throw an error. But if I try to use 5, which is available, I'm going to clear. If I try to use 5, which is available, I'm trying to remove 5. So if I run this code now, we'll get, see 5 has been removed. Okay, 5 has been removed. All right. So, but if you use the discard method, even though if the key is not found, there will be no error. All right, there will be no error. So let's go on and try the discard method. Now we'll say discard. Okay, and I'm trying to discard 15. We don't have 15. So let's see what we get. All right, you see, it gives us now the thing is that when you call the discard, it's going to return the set for you. Oh, sorry. Now we did discard, sorry, we did discard and discard didn't the element wasn't available, so it didn't remove anything. So we still have our set intact. So, but you can see um, if I say 12 and it removes an element from a list if or from a set if it is a member. So unlike set.remove, the discard method does not raise any error when an element does not exist. Okay. So now the thing is this. If you use the discard and the element does not exist, there will be no error. But if you use the remove and the element does not exist, there will be an error. Okay. So for it to be safe, you can use the discard. There will be no error thrown at all, unless you want to throw an error in case somebody is trying to access a key that does not exist. So you can also remove arbitrary element. Using the pop method, you can actually remove any element at all. So now the thing is that you don't know the element that will be removed. So if I say a.pop, okay, a.pop, it doesn't take any argument. So this can remove any element at all. We don't know. We are not sure. Now remember, this is unordered. So if I call this, you see it removed 5. All right, 5 was removed. All right. So it removed, okay, it will remove any element at all. So it will remove from what we are doing here is removing the first element in the set. Okay. Now, but the thing is this, it can remove any element. All right. It can remove either any of them. It can remove any element. It's just that we don't have enough time to go do this thing often. All right. You are not sure of the element is going to remove. You are not sure. You are not sure. In case you might run this thing for 50 times and we might see the difference. Okay. You are not sure of what is going to remove and it is not returning anything. Okay. So okay, let's try to do something. Okay, let's try to experiment something. So I'm going to do a while loop here. Okay, I'm going to do a while loop while while I is less than 100. Okay, sorry. Hmm. Okay. I'll create a variable I is equal to 0. Then yi is less than, let's try this thing 100 times and see if we'll get what we are looking for. I want to show you that this pop method can remove any element at all. So if I say I less than this, I will call the a.pop method, and then I would also call the print. I will call the print, and then I will now print out A. Then after that, I would increment, I would increment my I so that my loop can actually end at, oops, plus I is equal to, where are you? All right, so what's wrong? Yes, plus equal to, what's wrong? Hmm. I is equal to I plus 1. So why are you not giving me? Okay, I think, yeah, there wasn't, hold on. Okay, plus equal to, what is happening here? All right, no problem. I don't know. My head is not working fine here. So I'll just say I plus 1. All right. So now with this, let's run this. So what we have here in our set, we have 5, 6, 7, 8, 9, 10, and we are calling the pop method. So we are going to call this pop method 100 times. So let us see what we are going to get on our console. All right. So, okay. So, okay. All right, all right, all right, all right. I get it. I get it. Okay, so the first time you remove 5, the first time the second time you remove 6, the second time you remove 8, 9, 10 until you finished. Okay, and then it was now an empty set, and we are calling the. Okay, this didn't work. So I was trying to actually do something, but anyways, for now, the pop actually remove that is the first element from what we have seen here. Okay, so the pop. Um, what's the definition? Okay, so the documentation doesn't have much. All right, so the pop will remove the first element. That's from what we have seen here. That's what we are doing. Okay, and we got this error because at the time the set was not empty, and we are trying to call pop on an empty set. That's why we got this error. Okay. So what are the operations you can perform on a set? There are mathematical operations like the union, the intersection difference, and symmetric difference. So when we have this element like this, you can perform a union operation. So union is we are adding both of them. The both sets will be merged together. So they'll be merged together. And 1, 2, 3, 3, 4, 5 merging together. You can see because they have 3 in common, 3 will not be duplicated. We would only have 1 3. So you either use this pipe symbol to do the union, or you say A dot union B. All right, A dot union B, or you use the pipe symbol to do the union. So the union, you can use A dot B or A pipe B. Then it will just give you, it will merge the two things. It's just 1, 2, 3, 3, 4, 5. Now it will merge them, and because 3 is duplicated, it would only give you 1, 3. So that is what we have here. Okay. Now we have another one, intersection. So intersection will give you the elements that both of them have in common. 1, 2, 3, 3, 4, 5. What element do they have in common? They only have 3 in common. So A has 3, B has 3. So what they have in common is the intersection. So you use this ampersand symbol. You use this ampersand symbol for it. Now you can see that I'm not trying to do any coding here. I want you to think. All right, now we are getting to that level where we can be allowing you to do things on your own. But if you try it, and you didn't get it, reach out to us. But we want you to be thinking as a programmer, you have to be thinking. So A and B, all right, use this ampersand symbol, but there should be space in between them. Or you can say A dot intersection B. All right, try it yourself. Try it yourself. So this will give you what they have in common. Union will give you a merge of the two sets and then remove the duplicates. Intersection will give you what they have in common. We also have the difference. So 1, 2, 3, 3, 4, 5. What is the difference here? Elements in A but that not in B. Elements in A but not in B. What do we have? We have 1, 2. That is the elements in A but they are not in B. 1 and 2 is not in B. 3 is in B. So we are going to get A minus B, we'll get 1 and 2. So you can use A minus B as the difference, or you can use A dot difference B. All right, so you can call the difference method and passing the other set you want to check. So like I said, you're going to do this on your own. Try it yourself, and if in case you don't get it, please reach out to us. You can also do disjoint. Okay, sorry, I'm coming to that. Symmetric difference, all right? Symmetric difference will give you the elements in either set, but not both. So it's not symmetric difference will give you the elements that both of them have, the elements that both of them have that are not in another one. So like now, 1, 2, 4, 5, all right, are not common here. So 3 and 3 are in both sets, so it will not bring it. So we are going to get 1, 2, 4, 5. Now, because the elements in either set, 1 and 2, all right, 4 and 5, because 3 is in both sets, 3 will not be included. It's like you're doing a merge. This symmetric difference is like you're doing a union, but you're removing what they have in common. All right. So you can also you can use this symbol. All right. You can use this symbol. I don't even know how to pronounce that symbol again, but you can find it in your keyboard on top of 6. Okay. On my keyboard, it's on top of 6. All right. So, or you can say A dot symmetric difference. All right. So I think using the methods are even better because they are more readable. A dot symmetric difference. Okay. All right. So you also have a superset. A superset. Okay. Now, sorry. Set comparison. We can compare sets. You might want to compare set A and set B. So when you say is A less than or equal to B, it means that is A a subset. That means is A a subset of B. Does A contains what is also in B? All right. We have the superset. Is A greater than B? Now, does A have or has more elements than B? Then the disjoint is this. So let's see some examples here. We have A 1 and 2 and B 1 to 3. You can see that B is bigger than A. The things that are in A are also contained in B. That means A is a subset. Inside B, we can get what is in A. So A is a subset. So when you say A is less than or equal to B, you will get true because A is a subset of B. If you say is B greater than A, yes, B is greater than A because B is a superset of A. When you now say A dot is disjoint, all right, A is 1, 2, and we are checking, instead of putting B here, we are checking a new set, 3 and 4. So no common elements. When you say is A, when you say this is disjoint of another set, it means that they don't have, when you say is disjoint, it means that they don't have something in common. They don't have any elements in common. A and B have something in common, but this A and 3, 4, as I said, does not have anything in common. So that's the disjoint. Is disjoint will give you it will give you true or false depending on if they have any element in common. Okay. All right. So you can also do set comprehension. Now you can see I'm just taking my time here because I'm not writing much code here because these are the things you're supposed to have known by now. Comprehension, we have done list comprehension, we have done dictionary comprehension. So now, this is your for loop in the list, this is your for loop in the comprehension. Then what your variable is, and you're going to use curly brace. Remember, the difference between this list comprehension, set comprehension, and dictionary comprehension is that both of them, of course, both of them will start with curly braces. But in a dictionary, you're not going to do x and colon, then the value. But here we are doing x times x, which is the expression. So figure this thing out yourself. I want you to think. But in case you did not figure it out, if you don't understand it, take your time. Oh. Don't just reach out to us without figuring it out. Figure it out yourself, okay? Figure it out yourself. If you cannot figure it out, then you reach out to us. We'll explain to you. But we want you to start thinking. All right, we want you to start thinking. All right. So when you do this, you're going to get the set comprehension. If you really understand how comprehension works, list comprehension, dictionary comprehension works, this will not be an issue for you. Okay. All right. Now there's something we call frozen sets. Remember that sets are mutable. But in case you want to create a set that is not going to be mutable, that is not going to be changed or modified at any point, you use the frozen set. So a frozen set is an immutable version of a set. Remember, anything immutable means that you cannot change them. You cannot update them. So once created, elements cannot be added or removed. All right. So you will use frozen sets, then pass in a list or any iterable. So let's go. This time around, I'll do you some messy and I'm going to do something. So I will say A is equal to frozen set. Then I will pass an iterable. All right. I will pass maybe a list, a tuple, whatever it is. Okay. So with this, I'm going to create a set that will not be mutable. Okay, I'm going to create, okay, build an immutable or another collection of unique elements. So I'm here now. This element cannot be added. So I have 1, 2, 3. If I print A, I'm going to get that A. And if I try, look at it, if I try to say A dot add, you can see there's no add method on it. But even if I try to add, all right, I think there will be an error. I try to add 5. Okay, there should be an error. I expect that. All right, there is an error. It says that attribute error, frozen set object has no attribute add. That means I'm trying to call, the frozen set does not even have any attribute like add. So you cannot add, you cannot modify it. You can't. All right, you cannot modify it. So frozen set, whenever you want to create a data structure that you are not going to change the elements, you use frozen set. All right. Okay. So if you try to add or remove anything, you will say the attribute does not exist because add or remove does not exist on the frozen object. So what are the use cases of set? Use set whenever you don't want duplicates. Imagine that okay, let's say you have a list that have some duplicates, or you have you have a tuple that has some duplicates or something. So you can actually use set. You convert that list to a set. When you convert that list to a set, the set will remove all the duplicates, and then you can now convert the set back to a list. All right. So let me show you. Let's imagine that we have a list. We have a list, all right, and this list has 1, 2, 3, 4, 5. It has 1, it has 3. Okay, you can see we have some duplicates here. But in your code, you don't want to work with duplicates list. And you might not be the one that created this list. You might be fetching this list from a database or from JSON file, whatever it is. Now, since you don't have control over that duplicate list, what you can do is that you can say, okay, you can say set. I can say set list and is equal to, I will say set, all right? Since I'm going to convert this list to a set, I will now pass in list like this, okay? Then it will convert it to set for me. Then I can now convert it back to list. I can now say list is equal to, I can now call the list constructor function and pass in the set list. I hope you're with me. So look at what I did, all right? I have a list that have duplicate elements, but I don't want to work with that. I want to filter it and remove the duplicate. So what I will do is that I will convert that list to a set using the set function. Then later I will convert the set that I have gotten here, which will no longer have the duplicates. I'll convert it to the list. So if I go on now and print list, all right, it will give us now you can see we now have the last thing we have here is now 1, 2, 3, 4, 5. So we no longer have the duplicates here. All right. So this is one of the use cases of set. Membership testing. So in case you have a data structure and you want to be testing, you know, the membership operator now, the in or the not in operator. So if you have a data structure and you basically want to do membership testing, use set, because set, the operations will be faster and it will make your application faster. If you want to do mathematical operations like union, intersect, etc., you use set. All right. If you want to have unique collections where you don't have duplicate items, you will use set. Okay. So thank you very much, ladies and gentlemen. In case you don't understand anything, if you get confused in any of the brain work I have given you, all right, just reach out to us. Okay. Reach out to your instructor. They would actually explain, but try it. Try it first. Think. All right. Try it first. Then do your assignment, do your test, and I will see you in the next session.